This is still section 3.7. I'm on page 18 of our chapter 3 part 2 notes. The example on the page says a particle moves according to a function s of t equals, and they give you guys a function. T is measured in seconds and s is measured in feet. So the first thing says to find the velocity function at time t. So the velocity function is just the derivative of our position function. And so if you take the derivative of s of t, you should get 3t squared minus 3t minus 18. What is the velocity after 3 seconds? So we need to find the velocity after 3 seconds. So I'm going to substitute in 3 up to my velocity equation up above. And working this out, we get 0. We need to put our units, and this is in feet per second. The next part, C, says when is the particle at rest? So at rest, again, remember, was v of t, our velocity, is going to be equal to 0. So I'm going to take my velocity function, which we have is 3t squared minus 3t minus 18, and set this equal to 0. Factoring out of 3, we have t squared minus t minus 6 is equal to 0. And then factoring it from here, we have t minus 3 and t plus 2 equals 0. Using the zero product property and setting those each equal to 0, we get t is 3 and t is equal to negative 2. And again, we are dealing with seconds. So you can see that the negative 2 seconds doesn't make sense, dealing with time. So it's at rest at t equals 3 seconds. Part D says when is the particle moving in the positive direction? So positive direction again, this is where you're going to have your velocity. It's going to be greater than 0. So positive direction. So we have our velocity function, which was 3t squared minus 3t minus 18. We're going to say greater than 0 this time. We already factored this up above, so I'm just going to copy that down. And we have 3 times t minus 3 times t plus 2 is greater than 0. And from pre-cal, you probably remember doing these where you would make a number line. And we have zeros. It's equal to 0 at 2, negative 2, and at 3 from up above in part C. But again, time doesn't have a negative value, so technically it starts at 0. So anything to the left of 0 we couldn't have. So I'm going to go ahead and split this domain of our function that we have for our velocity from 0 to 3 and figure out what's going on and figure out if it's moving the positive direction or not, and then from 3 on to infinity. So I need to pick a value between 0 and 3. I'm going to go ahead and substitute in 1 into my velocity function. When I do that, I get negative 18. So this means it's moving in the negative direction. And then for the next one, I'm going to go ahead and pick a number 3 to infinity. I'll just plug in 4 into my velocity function. So v of 4, when I plug that in, I get positive 18. So this is moving in the positive direction. So the question was asking for when is the particle moving, so it's looking for time in the positive direction. So it's moving in the positive direction after 3 seconds. And then if you wanted to write this with math notation, it'd be t is in the interval from 3 to infinity seconds. So anything after 3. The problem continues on to the next page. And the next part says, find the total distance traveled during the first 8 seconds. And to figure this out, we're going to have to look at when does the particle actually stop and switch directions. So it started to move at time 0. We have to figure out where it was starting from. And then it switched directions. If we go back up here and look at our graph, it switched directions going from negative to positive at 3 seconds. So I need to figure out how far it got at 3 seconds. And since I'm asking how far it went, I'm using the position function. And then it wants to know the first 8 seconds. So I need to figure out when did it stop moving, where was it? So plugging these values into your original function, your position function, s of 0, plugging in 0, you get 30. Substituting in 3, you get negative 10.5. And then substituting in 8, we get 302. So the distance that it traveled here, if you do the bigger number minus the smaller number, which is distance, is 40.5, or think of it as a number line. And that was in the negative, went to the negative direction, and then it switched at 3 seconds and went in the positive direction. And if you do the bigger number minus the smaller number, you get 312.5. So the total distance that it went, adding up these two pieces, would be 353 feet. We will look at F together. So looking down here at part G, it says find the acceleration at time t after 3 seconds. So an acceleration function is the derivative of our velocity function or the second derivative of our position function. So we have our acceleration function is equal to 6t minus 3 if you take the derivative of your velocity function. And it wants to know, find the acceleration at time t, that would be this, and then find the acceleration after 3 seconds. So 6 times 3 minus 3 equals 15. And the units are going to be feet per second squared. So the next one on here says, when is the particle speeding up and when is it slowing down? And in order to do this, we have to look at our velocity